All right. Okay, cool. Well, listen, if it's just, we can ask whatever you want, and I'll even give you some future looking stuff. Um, anyway, so this is kind of what I pitched in the thing, and I'll tell you why. You've seen this camera thing, and you know who I am. Anyway. Um, yeah, in my past, I was an IT guy, and I actually started a magazine called Windows NT Mag in the '90s, and it went worldwide. It was 160 countries, 13 languages. It was a partnership with Microsoft. Yeah, and anyway, yeah, you might have read it. So IT and software were my gig, whereas David was the oil and gas engineer and stuff like that. So anyway, but and I don't know if we didn't mention, but we got the top innovator of the year award from Darcy Partner. Are you guys a member of that, or do you even know? It's like an analyst group thing, kind of like Gartner. Anyway, the cheat sheet, that's one of the things I do. All right, so I'm just going to tell you. So a large operator, who I will tell you later, since this is being recorded, I'll tell you exactly who it was off mic. Anyway, they came out, and it was ops who brought us in. So they said, hey, why don't you build out 11 new sites without hiring night operators, or night riders, as you call them, right? They want to eliminate gate operators, eliminate 50% of their call outs, dramatically reduce risk exposure to emissions and safety violations, prevent liquid leak safety related issues. Also, I found out later, they were under a consent decree for tanks. So, which will explain why they wanted us to do tank monitoring first. Okay. Anyway, we knew permits, and they did actually with our stuff. They won the largest set of permits in Colorado all at once, because they used to do onesie, twosie, 8 at a time. They went for 33,000 acres all at once, every bit, and they won them all. So they have 8 years worth of permits. They did it, and it was a winner take all. So I knew we picked up client number 2 right after they lost. They came literally hat in hand saying, we got to spec your stuff on all new permits. And like, all right, so we paid an engineer, and he helped them crank out. So now we're on every new site with the second operator, but they lost to the first operator, and it was winner take all. And honestly, after they won, they came over to the office and said, dude, to be honest, we already won. Like, you could just put your stuff out there and didn't even need to work, because we already won the prize, which was 8 years worth of permits at once. But we want it to work, right? So, but anyhow, they won these permits, and it was a big deal. And they wanted to get our solution approved by Colorado and do all the above with a positive ROI. So that was the list. They said, this is what we're going to ask you to do. And they said, hey, we're going to own it. So we care about automation, safety, efficiency, and emissions, because they came into it knowing, hey, emissions is an ops thing. Yeah. And then HSE, they said, hey, we will bring them in for you. And then sustainability said, hey, we'll interface when the time is right. But basically, ops owned it and said, no other department will derail this this process, kind of. So they kind of own this thing. So this was actually designed. Okay, so this is the suite that this operations group wanted to put together. They had this in their mind, and they said, if you do this, leak detection, quantification, the gate guard wasn't in the original one. Hard hat, flame smoke, ECD, liquid leak, the tank monitoring was big for them. The audible, they want a couple of these audible things. So they want to continually know the compressor run status. And I didn't go into that because it's not a very visual thing, but that does 2 levels. One, there's a mic on it, and we can tell when it's running on or off. But we also, one of our guys, director of AI, he has a patent on sound things. So what we do anyway, is, okay, you know how like you'd be out to eat and you're your song and your wife, hey, what's the name of that song? And you can put that app up and it will listen to 10 seconds. We have sound of compressor run status that literally we can take a sound bite of 10 seconds, run it against, and we can tell you it's like how well it's running.
Get that in.
Oh, you did? Okay, cool. And then security, the security thing and the pumper truck deal they wanted. The Prove Zero was added later, and the gate guard was added by the second operator, okay? Now, this little chart here was actually put together by the operator. So this is what we did, because I said, hey, here are all these things, but how do you see these? Like, how do you view them? And so they said, well, hey, all these are for, there's a regulation for all of these, but they said safety is check box, all of them. Then they said, hey, all these are for reducing greenhouse gas. So you can see some are, they're all safety related, then permit, and then ops. So the ops guys gave us this little grid here, which I said, so I'm like, hey, all these are safety related. So let's look at that. This is our process that we do. So when we start out with a new client, we do the three levels are monitor, measure, monetize. So monitor is first. So we do discovery, figure out which sites, what they look like, configuration. Then we figure out how we're going to integrate it with SCADA, and then we put the, you know, the computer vision stuff on there, right? So that's the first one. If you're not familiar, but you probably are, the OGI cameras, CVOCs, which is pretty much in a simple way, eens and ains is what, you know, and a bunch of eens and ains, right? Then you've seen this one here, but you know, where we mount it up on a pole, and camera placement is pretty key. So we've got it down now to where we go in, we have a drone that goes up there and we look at the optimal thing. And so we can see which angles are best so you can fit it in there. And yeah, and then we get approval from whoever owns the site, ops. Okay. And then it's we have usually there's third party guys that already have MSAs that come in and actually, you know, do the infrastructure and do all this stuff. This is what a bird's eye view look of our camera looking down. And then we do the tour stops, which I think you've seen this, but this is really key. And we help do this, find the optimal, because what we're looking for is the tour stop, name it right. And then we also now tie that in with the subpart W component level. So we can make sure that it covers all of the required LDAR stuff that you're supposed to cover.
We're strictly talking the camera now.
Yeah, yeah. Right. Yeah.
Can we do
we can do this with the methane only, or the other one is same thing.
They both can't. One camera can't do both. Right,
So the cooled core can do everything because it can see all the anes, enes, and all that stuff, right?
Yeah.
The methane can see the methane only, but it's also an IR camera, so it can do liquid leak, can do a lot of things. It's not just gas.
So all this prep work, we do this in a simpler way with satellite photos.
Yeah, so we usually start off with like the Google Earth photo, like where you see the layout of the site, and we can literally spot and dot something like that ahead of
I'm
time.
just looking long-term and cost and deployment. And if we're doing site survey teams, all these sites, it's probably hard.
Yeah, we mostly, we're pretty good now, just literally with the Google Earth drawing, you know, and if you have, there's some other stuff that we do that I'll show you where, you know, if we have other engineering, like we can like if you had engineering drawings of it, you know, like because we're really good with some of those other models, the 3D models of sites, if you had those.
Just got offered to get 3D.
Oh, is that right? Okay.
Well, we're flying helicopters around our equipment, and said that they could 3D model it if we want.
Okay. You know, we're integrated here on SCADA, right? So you got the cameras, the edge, you know, going to the SCADA system, which is, you know, the point of truth. And then we have our dashboard to set the alerts and stuff. And then, you know, the other more visual alerts you can get. Okay. And we do integrate more with SCADA, and I'll show you some stuff like that. But
and it would be a multi-connection. So some certain data you'd be looking at would be going to Ignition data, but some would be going to our dashboard.
right. Yep.
maybe somebody like a Valadier or
Yeah, I mean, because we can API into anything up here, right? So. This is what we had to do to get our alt aim, right? Source level detection, blind testing, LDAR equivalency using the LDAR SIM model, the alt work practice. Two operators endorse it, which is PDC and Civitas, that's public. And the EPA approval from EPA Region 8. And then the alt aim Reg 22, so it adds all the stuff from Reg 7 is approved alternative workflow, approved tank level monitoring, approved loadout observation, and an alternative for Appendix K. We've got plus we got approval for a GHG intensity reporting. So source level leak quantification and duration, bottom up, measured informed inventory, ISO 14001, which is a GHG certification. And then we also included in our protocol how we do it, the Clean Connect stuff. Okay. And so all that's geared up for an audit in 2025. This is the workflow: detect, diagnose, repair, verify, report, and retrain. And so the way I like to look at it, this is the sort of the future version right here. So imagine guy gets an alert on his phone, clicks on it, you can see the live video. This is what happened. It's annotated. You can see the quantification. We even try to diagnose it, right? And then you can confirm the diagnosis or say, no, it's a maintenance event or something. Then our clients are literally allowing us to tie into the SCADA. So like to reboot a separator. So you can fix the cold venting event remotely. So the way I like to do it is this: you're at your kid's birthday party. The old way is you get an alert, somebody gets in a truck, drives out to the site, and you miss your kid's party. The new way, you get an alert, you see it, crap, you fix it on your phone, you put your phone away, an hour later, it alerts you and says, hey, I verified it's fixed, I closed the ticket out. So we have a workflow system built right in. That was government approved, which is cool, right?
sounds good. I don't think we'd ever allow it to interface with our process control. But still, you could use that data to hop out.
Yeah, just hop over to your actual app and do it. And yeah, so we don't do it, but you do it on some other SCADA system, right? So how the EPA and the new rules looks at technology, scanning technology. So fence line monitors, planes, satellites, open path lasers, those are scanning. What they mean is once you get an alert, you send in the inspection technology. So inspection technologies are method 21, periodic OGI, so a handheld OGI, and ours, continuous OGI. Why? What's the diff? These can see the source. That's it. I mean, so we can see the source. So if you want to see the comparison, this was provided by a client. So they said, all right, well, they had a fence line monitor around their site and they did a blowdown event. And the fence line monitor didn't go off at all. It didn't even reach 1 part per million. So they provided this client provided this and said, here's what your camera saw. You see the blowdown, you put your colors around it, you give us a quantification, pretty dang clear what happened, right? This side, it didn't go off. So that's the diff, right? And this is provided by a client who we thought was going to be like so pro fence line monitor, and they came in and literally went a 180 and said, no, we're done. Leaks are not random. So here's what we're seeing on, and again, this could change over time, but we see cold venting, tanks overpressuring, loadouts, and then other. And that's what we're seeing. So this stuff, what's cool about cold venting is all of our clients with modern gear have been able to fix this remotely. Like just reboot it. What happens is the pilot light goes out and the state is off. So SCADA says it's on, but it's actually off. So they reset the state. Tanks overpressuring. We're working on this with the clients because they see it over and over and over again. So they're like, how do we fix this, right? Loadouts, pretty easy to fix. You call up the pumper truck company and tell them that if they mess up again, you're going to fire them. And they said, well, we didn't mess up. Dude, I saw your truck arrive. I read the license plate. I saw John Doe get out. Literally, everything is observed in real time. There's no way to wiggle out of it. So now there's other stuff in here. We see compressors leak. You see other stuff. Okay, I'm not, but it is so not random. And unfortunately, the way the regs are written, as if leaks are all random. They're not random. I mean, there's certain stuff that ops sees all the time, which means that its emissions are an ops problem. The big change we see here is the impacts of Reg C is number one is staffing and call out. Okay. So this is, I don't think a lot of people have done the math, but I started doing the math here, right? Just to give an idea. So this is part of my cheat sheet. And the big thing here is LDAP frequency is going from quad 08 every 6 months to quarterly, and also with quad OC quarterly, right? And the big deal here is this is all the sites from November 15, 2021. This is all the sites before, all of them. Nothing's grandfathered in with quad OC, zero. So unlike quad OA, which kicked in 2015, quad OC says all sites are covered. Now, I've had people call me up and say, quad OC literally is increasing my LDAR by 700% because it's covering a whole bunch of sites I never even had to look at, right? Now, how does that compare to Colorado Reg 7? Well, Colorado Reg 7 is monthly. And for pre-production, Colorado is continuous. From 10 days before the drill hits the ground, all the way through the first 6 months of production, it's continuous monitoring required. So Colorado is even still beyond that. Now, just to give you an idea what that looks like, here's Colorado's LDAR 21 summary. 147 companies reporting, 14,796 sites inspected. Check this out. In Colorado alone, there were 599,006 inspections. So in 2021, Colorado did more LDAR inspections than all the rest of the country combined. That's the level that when you go to monthly, this is how big it was. Average 40 person. This is all from their actual LDAR summary. So Colorado, dude, they're spending a crap ton of money on LDAR. Okay. If the average human can do 400 inspections, then you need 1,497 inspectors in Colorado. Okay, so big idea. We said, hey, what if you could reduce 85% of your LDAR schedule callouts by doing automated? That would eliminate 509,000 callouts in Colorado alone, right? If they started little by little replacing manual LDAR with autonomous LDAR. Putting a person in a truck and sending them out to a site is the #1 safety issue, according to the operators I talked to. In addition, it saves a lot of money on people, trucks, and insurance. And in some states, like Colorado, they're requiring all the operators to replace their entire fleet with EV trucks, right? But I tell them, hey, it's a lot cheaper to lower the need for trucks rather than replace all your trucks with EV trucks. If you can eliminate a lot of callouts, right? Now, here's the math for Quad OBC. You're going to get, so you double the frequency so you have to do 2 times a year. Now you got to do 4 times a year. And you got to do 4 times a year, but all the sites going all the way back to 2003. So I started doing the math. That will cause operators to add collectively across the US 1.6 million new LDAR inspections. That's a 471% increase. So using the EPA's formula of $600 per LDAR, that's an extra $831 million of LDAR expense. That's the real math that will happen. I don't think a lot of people really realize the impact of Quad OC. It's just a crap ton more of sites that you didn't have to cover with Quad OA. Now, some voluntarily did it. Some were doing it anyway, so that increase would be baked in. But a lot of people did the minimum and didn't do it, okay? So other stuff we do the tank level monitoring, you know, using the long wave, and we're as accurate as guided wave radar there. And the liquid leak that we do. And now this liquid leak, the first round was done with the fixed mounted cameras that we're looking at tanks and stuff, but the new one we have is part of the rotating one. So now we can do liquid leak on tanks specifically, but we can look at liquid leaks all around now. And we also modified the computer vision model to do the first phase one just did really quick leaks, like pinhole leaks that were quick. The next one will look at slow leaks that literally take like a day to accumulate or more, which tends to be the kind of ones that you get right before a fire tube failure. The hard hat we do, which is also doubles as a security one, the flame and smoke that we do, the ECD monitoring that we do, and I have some else I can tell you later about uncombustion efficiency that we're adding. The virtual gate guard, this was actually added by the second operator who they needed to let go 45 gate operators. But again, it looks for trucks, it reads the license plate, and it looks against an authorized list of plates. And again, you know, this Alt-AIM workflow, the one I showed you, it works for all the models the same. So when you get an alert, it's not just gas leaks, you could get it for liquid leaks, you get it for flame and smoke, you get it for whatever. So now you have that same sort of detect, diagnose, repair workflow that'll work for any of the models. The only one that doesn't send alerts on, unless you wanted it to, was the tank level monitoring. Like I don't know exactly why you'd want to send alert unless maybe you did, but usually SCADA handles the tank level stuff, right? Because we're sending through not video, but just levels that mimics like a guided wave radar. So on the measure side, what we do is because our model, so we do real-time monitoring, real-time situational awareness, but models talk to each other. So one of the beauties of the root cause analysis, we can actually look at models together. So the models do actually talk to each other, which is kind of weird because they're AI, but AI will inform each other of models. So that's why it gets smarter as well. Like for example, let's say we see tanks overpressuring, but we're also looking at the tank levels simultaneously. So can we predict when a tank will overpressure? Kind of interesting. We're starting to see patterns in tanks overpressuring, like liquid leaks, and like liquids that fill up really smooth, because we look at a time series of data. So it's moving really smooth, and all of a sudden there's this sudden rise or sudden drop, and it creates a pressure situation. So anyway, correlation across multiple models working together. So safety. So we've had liquid leak detection, prevent fires near combustors. Our operators will tell us, hey, especially the sites that are near a community, like within 500 or 1,000 feet, those get to be not only environmentally bad, but it's PR and a bunch of other crap that happens when they're near a community. Pumper truck monitoring we do for P66 and a midstream terminal. They say it prevents, each dome out we prevent is $1 million of savings. And I didn't tell you about the P66 stuff, but liquid leak, fire tube failures, each one of those, if you catch it early, it's a few $1,000. If they fail, it's expensive. Gas leak detection, looking for seal gaps in floating roof tanks. Again, some of the operators have consent decrees. So, you know, it's like they want to fix those things. Fire detection, prevent site fires from spreading, explosion detection. I don't know exactly what that would say. Tank level monitoring, eliminate opening thief hatches for maintenance. So that was one thing that someone got a consent decree on, because even though they had guided wave radar, they had to actually open up a thief hatch to every day to clean the dang thing off, because it would build up with wax or whatever, you know. Gas leak detection, minimize exposure to benzene and other VOCs. And there's a bunch of refineries and stuff that want that just for this, just to have us look at stuff, because they have consent decrees around benzene. Build out new sites without hiring night operators. Again, the operator said, hey, that would save me 60 million bucks over actually 10 years. Autonomous gate guard, that was saving them 40 grand a month. Increase in LDAR inspections. They're eliminating a lot of callouts. But what's really different is the operator said, hey, I'm the most senior operator said, I can manage 30 sites myself through this deal. So, and what's really cool is I'm watching them 24/7. So he said he used to send guys out, a runner out, to go see what was going on, but he said, I'd have to look through their eyes. Well, what do you see? Well, what's happening? He says, I don't need to call them anymore. I'm literally looking at the screen going, yeah, I know it's so having your most senior people be able to help with a diagnose, but be able to diagnose across dozens of sites is helping them out, right? Liquid leak, fire tube failures, you know, again, preventative maintenance. The big deal here is, oh, and then on the retrain side, we use deep learning training. So this is done now by multiple operators where they do controlled releases. They do it with a high flow sampler. We look at that video on the OGI video. We run through a deep learning model. Then we check blind test data, and we say, hey, is it getting better? Is it within a certain goal of accuracy? If not, retrain, retrain, retrain. So we went through an initial set of training. The operator said, hey, you're really good. Like we're good enough for ops to be able to get a relative size on there. Now we're going through that next round of training to get it even more and more and more accurate on even the smaller stuff. Now, why it came into play is because our alert levels. So we allow operators to set multiple levels of alert for each tour stop. So you can get the leak source, the quantification, and the duration. Then you can set alert levels at each tour stop. So level 1 says, hey, I want you to log it. Just record it. Don't alert anybody. Level 2 is, hey, alert an individual. And level 3 is alert a bunch of individuals. Like it's on fire. Send it to 10 people or whatever, right? Or so we have each tour stop allows 3 levels. And that's why quantification will kick in and say, because they'll say, hey, it's this big or it's this long. We want you to all hands on deck kind of thing. What our ops tell us is cycle speed is key. So if the faster I can detect, diagnose, and repair, especially like cold venting or something else, the less problem I have and the better I get back to my site running optimally, right? The key is the speed, especially when it comes to, like our guys are ready. We can send satellites out right now with looking for super emitters. So super emitters look for 100 kilogram per hour leaks, okay? And I checked they're here today. It's GHG sat. I said, could you see a 100 kilogram leak? They said easy. And we're going to be over Permian 5 times a day. And I'm like, okay. The Clean Air Act sets a cold venting, like an unlit flare, at $37,500 times the number of days since your last LDAR. So traditional LDAR, let's say that you found it, you know, almost at the end. So you checked your LDAR, and now it's 90 days later. On the 89th day, you have an unlit flare. That's your fine, times the number of days since your last LDAR. With our alt-aim, our LDAR is done every hour. So like, okay, but we find them so fast, we're not going to even get to that. So a cold venting vent will accumulate 100 kilogram hour to be seen from space in 3 hours. So just one cold venting thing at night goes off, it will be seen, right? EPA is proposing raising the unlit flare thing to $100,000 a day. So they kind of want to get rid of those. All right. The reporting framework, this is what we do with our Prove Zero thing. So we have the computer vision, we tie into the telemetry data, like to read the meter stuff so that we can do the throughput, which is the GHG or methane over the throughput, okay? And we have automated already the S&P methane performance certificate. But I use that data or that process to apply for Colorado's Reg 22, which is GHG intensity report, and which they've accepted. So the difference between the S&P is not source level. Reg 22 is source level GHG intensity. But I have mapped that one against that OGMP and the EPA methane. Pretty much this data will do all three. So it's great. I mean, you get it done. One set of data can do all three things. And if you have any investors who want to have proof of emissions or whatever, and I have a whole thing I'm doing tomorrow for 4 hours where I'm going to go deep into the SEC reporting. So we actually are working with the report company here that Civitas hired to basically feed them the data they need for LDAR reports, emission inventory, and the SEC climate risk reporting. So this is what our ops guys tell us. Hey, number one, it's permits. You guys help us win new permits. People, it's hard to find qualified people, so they like to clone their best people so they can be in more places at once. Process, they want to manage by exception. Efficiency is built down. They want to do, once they get used to RMM, they want to keep doing it. Like, I want to do as much as I can remotely without, reduced call outs. Proof, prove that you're producing clean energy using government approved methodology, which is our Prove Zero thing. Product, by detecting and fixing problems quickly, we enable our operators to create a better low methane intensity product. And if you do all the above, you get a profit out of that. So it happened to work 6 Ps, right? Predictions, the hardware, OGI camera, PTZ units, edge device, they're all getting better, faster, cheaper. Moore's Law. We're benefiting that because we were agnostic about those. So we had hardware companies competing for our business. So it ended up getting better, faster. Computer AI vision is improving. Honestly, I'm in this business, and when my director of AI comes with a new model change, even Dave and I go like, dang, that's getting good. Like it's getting scarily good, right? But it can always be better. We're always like, dang, that was better, but we can do better. So it's, it keeps improving. RMM software will revolutionize the way operators manage field ops. And I do think it will even change the way service providers, where people are going to do more like compressors as a service, combustion as a service, right? In other words, they make money when stuff doesn't break, not when it does break. There's one other thing that I didn't tell you about, but we have a joint, so we're working with Antea, and they do asset integrity management. And so we're working on something so we can tie into, like if you had refineries or midstream, like with lots of parts, we can actually, our two systems can tie in together. So for example, they're doing x-rays of wells, they're doing x-ray stuff, so the preventative maintenance stuff, which we're then ingesting through our computer vision. And their big idea was this, which is, hey, Antea digital twin plus our computer vision equals digital twin 2.0. Because nothing like seeing a real video like of a part and you tie back into the source data, like literally the underlying physics of the data of the part. So yeah, there's a couple of refinery stuff we're working on where we can do digital twin plus our computer vision. So anywho, there you go. That is. That's it. That's a software company. They've been around 30 years. They're mostly in downstream.
So we got a group that's in a digital. Where they're at, or how many decades it take to get everything in digital.
Yeah, right. I know. But I'm just telling you to where we're going, because they, going through the asset integrity side is an interesting angle into refineries and stuff, because when you're looking at real time at, gas leaks and stuff, to be able for us at the source level to tie back into the, down to the asset level. Because a lot of the refiners go, man, when you're looking at this OGI image, there could be 100 parts in that field of view. You tell what the parts are and say, well, if we tie into Antea, I can get down to the source level.
Because they already have the sources all mapped out in their digital twin. So it's just a way for us to get really source level.
Over at y'all's area, you've got that camera.
Yeah.
That's your OGI camera. You
Yeah,
offer
so
that. What about IR? IR, do you just use anybody's IR camera and then?
we have 2 cameras that we help co-develop. Okay, so we'll use anybody's, but if you don't care, we have 2 cameras we have. We have a cooled camera that's the cooled, you know, the mid-wave thermal. We have an uncooled camera, which is a methane only. So we have 2 of those.
So your camera that does methane on, and the IR thermal?
Yeah, they're both infrared. Yeah.
You can warm them up.
Yes.
We've done some extensive pilots with the IR cameras.
And I know which one you're talking about, and I can tell you why it doesn't work. But we will talk at a different time under our NDA, and we can tell you exactly why it doesn't work. And I'll tell you why ours does work.
So with that same camera that you say that thing, IR camera, that camera can also see black smoke and pilot light?
We would recommend having the optical. There are certain things that work better, like for black smoke, having so we have that multi-sensor optical. It does a better job at the black smoke. But yes, we can see, and our camera does speciate between different conditions. So people say, hey, will it work in fog? Will it work in rain? Literally, you could go over right now, Luke could pull up every one of those conditions: snow, fog, smoke, everything, and we can see through that stuff.
Which camera would do?
You're looking for the one camera that does it all. Okay. That's the thing that David will show you.
That's the game changer.
Okay.
I could solve operate by priority, surveillance, and methane detection.
Okay. So go bribe the guy, and he'll just pull it around the side, make sure nobody's around. He will show you this next thing. Yeah, whatever. Yeah. But we're all good on the paper side, so yeah, we can show you.
Yeah, most of my questions were around that. How many cameras to solve all these different use cases for this?
Right. So I'll tell you right now, with our early adopters like Civitas and PDC, right? They have we built these, you know, over time, right? So you might have the one cooled core camera rotating around. They have some fixed mount ones on either side of tank batteries because they're only doing tank stuff. But they don't care because they're like $5,000 each, and they just expensive, and they last literally 10 years with 0 maintenance, right? So they didn't care. They had one camera going to the gate, so because some of those optical cameras are great at fire, smoke, PPE. They're great high def, but sometimes when you're in a fast moving vehicle at night, they don't pick up the license plate or read it super accurate. So yeah, we'll have a few cameras doing things. Are we moving toward the one, like the Uber thing that does it all? Yes, and does more.
Your solution is to have an edge box?
Yes. And the edge box, like you saw that one in there earlier in the slide, it was kind of a bigger unit. Our unit is shrinking. Each rev is shrinking by a fourth. So like our original unit, we threw so much GPUs at it because all the computer vision models we've got now that down to a 4 inch by 4 inch, use the NVIDIA, I forget which model it is, but so anyway, the edge box is getting smaller as well.
All your processing is done on site. The only data being backhauled is your alarms.
The exception data. And honestly, you can set it at the tour stop level. So, you know, if you're saying, I want you.
Tour stop. Talking about zones.
Zones, right. And, you know, obviously some stuff doesn't have zones like PPE and other things. So you have to say, here's what happens. So we get down to your SCADA system. Now, the first client, they were using Signet, but they had augmented their own sort of video management system. So we pull data directly, they pull alert data into their system and have their own little custom thing that their IT guys did. So they get alerts without us sending it up to the cloud. But at each tour stop, they can have 3 different alert levels and they can say, hey, I want to log this event. And so we can log it into AWS in the cloud. Okay, so that is an option. Or we could say, send that alert just to your systems out there. So we're pretty IT friendly, you know. All the 2 companies that we work with, like that we've scaled with, actually all of them, we tie to their IT stuff. So
We like to change everybody's offering. So like one we're rolling out now, it uses their standard. You got the edge box that goes to the server. There you can email out to phase 2, you know, that server basically goes away and then that data is going to go to the cloud. And you integrate with other vendors. So if, say data coming from a perimeter alarm, from another OJAC camera. This isn't a GameStop by any means. I'm just curious.
Oh, yeah.
Do we
I mean,
utilize
yeah.
something out there?
I mean, so the answer is yes. I mean, we've been camera agnostic forever. And so, but we will say, because sometimes bigger vendors, what they'll say, hey, we've had, or ops, they'll say, hey, we bought a bunch of cameras for this other thing. It didn't work. Can we cannibalize these cameras? We'll say yes with an asterisk. So we'll try them, we'll put them in. There's a lot of cameras work fine. Like we've tried a bunch of stuff. There have been a few cameras. I can tell you there are certain variations of Axis camera. Like we use Axis. Their 4-sensor, multi-sensor works beautifully. But they had another IR camera we tried and we go, dude, this sucks. Like the image quality. And we'll show you. You'll see it clear as day. Like
Surveillance and most of all. Multiple different access cameras.
so some of those, and we tried literally dozens of these things. So we can tell you pretty much like what down to the model, like, and we'll show you examples why it does or it doesn't.
The reason I asked that question is I'm trying to figure out if we still need a third-party software like Validator. You do some things that Validator does, but
Yes.
do you do enough that we wouldn't need that? We still need that. Because you got other things you got to do, like certain groups need that data, and there's going to be other sources. Like
Right.
There's going to be satellites information coming in, there's going to be flyovers. And that data needs to be manipulated a certain way for air compliance. It needs to be a certain way for a lease
Right.
operator.
So there's a bunch of these companies that are coming out with these sort of cross-technology reporting platforms, right? Like the Iconic Air guys over here. That's the one that Civitas bought. So we're like, all right, you want to do that? We'll be a data feed for that, and they can use it for whatever they want to do. But the hard calculation stuff of trying to comply with OGMP, like honestly, some of these reporting platforms, they're just a reporting platform and they have no data. So they're literally going back to the operators saying, hey, I need data in here. Like, yeah.
So we're not. Yeah. Part of that. Hard doing that.
And one of our operators is doing MIQ, but they're using our prove 0 to actually prove the methane intensity part, because MIQ doesn't really have a specific method. Like their technology